example number 2, and they are telling us to, our question for part A was telling us to get the stationary points of the curves and distinguish between them. In this case, this is our curve, y is equal to x cubed minus x squared minus 5x plus 6. They want us to get the stationary points. But I think to get the stationary points, we have to first get those stationary points and determine the nature of the turning points. How do we do that? We start by differentiating. So in differentiate, we have to get the y dx, which y dx is 3x squared minus 2x minus 5. This is our y dx. But we know very well that at stationary points, the principle is that gradient function is always equal to 0, because the y value is not changing irrespective of the change in the x value. So y minus y gives us a 0 in the numerator. Now at this point we shall come and set 3x squared minus 2x plus 5 is equal to 0. And here we have our sum as equal to negative 2, this one here. Then we have our product. We want to factorize. Is a multiple of this, which is a negative 15. Then our factors, we are going to deal with splitting this one to get the values of x. We shall have a negative 5, then we have a positive 3. This one gives us 3x squared plus 3x, then minus 5x, then minus 5 is equal to 0. We factorize out the common terms here, and here we have a 3x as a common term. We start with x plus 1. Then here the common term is a negative 5. We start with x plus 1 is equal to 0. Such that 3x minus 5 into x plus 1 is equal to 0. Meaning that x is equal to negative 1. And also x is equal to, this is a positive 5 over 3. After establishing the values of x, for us to be important to get the nature, we need to get the sign of that. So we get the value of x, we need to get the sign of the y dx on the left and on the right of the x values. So sign of y, so this is value of x, our value of x. We have to go ahead and establish the sign of the y dx in our table like this. So we shall have something like this in our table. We go to the left of the first value of x, which is negative 1. This is the smallest value. Then you go to the right. Then I can split with 2 lines to show that I'm going to another value of x. But before I reach that value, I put the left of that value. Then I put the value itself, which is a 5 over 3, 1.66 recurring. Then I go to the right of that specific value. Now I'm going to substitute in. When I substitute in, what will I have? I choose a value that is on the negative of negative 1, that is on the left of negative 1. For example, negative 2. When you put in negative 2, which sign of y dx do we get? Negative 2 will give us negative 3 heading. It will give us a positive value. Which positive value we saw is like that. I said this is positive, then something like this is negative. So this is our positive, then this is always a 0, leave it as it is. It's a constant pair like that. Then we choose a value that is on the right of 0, but it shouldn't exceed this next value of ours, 5 over 3, 1.66. So our value that is on the right of negative 1, we can choose a 0 and we substitute. We are substituting in this function of y dx, not this one here. Because the sign we are getting is of y dx, so we substitute here. When you put in a 0, you have a negative, which is this, and the negative I've told you is the one that points down like this. And when you look at it, it is in the form of a maximum. So this is the maximum turning point. When you look at it, it is like this. Then we also go here and choose a value that is on the left of 5/3, but it shouldn't exceed, this is 0. So the value there is going to give us a negative, ideally this and this, because we are choosing almost the same value on the same gradient function. So we choose, this is automatically going to be the same as this one here, negative. Then negative is like this. Remember, this is negative, this is positive. So negative points like this. Then this is automatically going to be 0. When we choose the value that is on the right of 5/3, since we don't have any other value of x, we can choose, even if you choose 100, it is automatically going to give you what? A positive. Which positive is in this form. It increases like that. So when you look at it, it is in the form of, which is a minimum. So we are going to conclude and get that we have established the nature of the turning point. Wherever there is -1, this is at a what? A maximum turning point, but we need to get the value of y. So how do we get the value of y? We substitute in the equation, the initial equation now. So our y value, if I put in -1 for x, it is going to become this. It gives us a 9. So the coordinate becomes x, which is -1 and 9. And we are saying that this is a maximum. This is the maximum turning point. Then we also go ahead and substitute in the value of x as 5/3, and we shall have, this is, if x is equal to -1, then if x is equal to 5/3, our y value is going to become, our y value will become 13. Maybe it is 13/27, something like that. So we conclude and say this is 5/3, then 13/27, and this gives us the minimum turning point. So we have established a stationary point, and indeed stationary points are turning points. This is the maximum, this is the minimum. So finally we shall conclude with the example in part C, which says, C says y is equal to x squared plus 16/x. So this is, we are going to go ahead and differentiate. Negative. So it is -13/27, this one here, if you substitute. Then we are going to look at this example here. When you differentiate